Good morning, good afternoon, good evening, wherever you might be. Thank you so much for joining us for this Power Hour and making time available for this. We appreciate it. We'll get going with this TBC Power Reality Capture Data Analysis Workflow Enhancements in TBC 2025.20. That's a mouthful. So today we have a full team in here. Myself, Tavish Comrie, Jonas Collier, and Mustafa Abia. Would you please introduce yourself, guys? Let's start with Tavish and then just work your way down just to quickly tell everyone who you are and what you do at Trimble and TBC specific. Thanks.
Thanks, Albert. My name is Tavish Comrie. I'm a TBC product management intern, primarily working with feature extraction in TBC.
Good morning. I'm Jonas Collier. I'm a QA engineer here at Trimble.
Hello, my name is Mustafa Abidi, and I'm the survey software test intern for TBC.
Great. Thanks, guys. And everybody, hopefully by this time knows me. I'm Albert Oliver. I'm the technical product manager. I'm the guy that sets up all these webinars and does a little bit else in the back end as well. So into the agenda, we have a packed one today for you. So we'll start with some point cloud classification improvements, jump into the curb and gutter workflow changes, AgileAssets Connection, show you what that's about. Talking a little bit about ESRI Feature Service for PCI, pavement condition inspection and how you can utilize that. Then the batch ortholane processing, and then we'll go into the Q&A and resources. So for the Q&A, please use the Q&A in your menu and not the chat. The Q&A gets recorded, so we can reach back out to you if we don't have everyone or don't get around to everyone's questions. So please use the Q&A for any questions. If it's something really relevant and to the conversation, we'll stop the slides, but I think we'll try and work through the presentations that the guys have put together for us, and then we'll get to the Q&A afterwards and take some time to get through all the questions you guys have for us. So with that, Tavish, over to you guys. Go for it.
Thank you, Albert. Yeah, the first feature extraction enhancement we are highlighting are the improvements to the outdoor terrestrial model and to custom model training within the point cloud classification command. So in TBC 25.20, we transitioned from an older model to a newer one for our outdoor terrestrial classification. This change enables different model parameters and more trainable weights to be stored. As you can see from the table, this new model has significantly improved the accuracy behind a few classes such as sign plates, poles, and noise, with an improvement also noticeable in wire classification, amongst a few other things. Some examples of this improvement in action are shown in the slide. The improvements are clear on signposts and poles, shown in the top images. In the bottom left, you can see an improvement for vegetation, and in the bottom right, you can see an improvement for the ground point class. The other feature in the point cloud classification command that has had a model update is training a custom classification model. This has resulted in a significant improvement for training speed, while also providing a minor accuracy improvement as well. The major change on the back end is that the new model no longer uses pre-trained weights, which is the key reason for the speed improvement. Minor changes, such as no longer using complete files for validation and no longer showing training accuracy alongside validation, have also been implemented to improve speed. Training accuracy always improves, especially with high accuracy from the start, but that accuracy is redundant because of course the model will perform best on data it was trained on, whereas validation accuracy actually shows its performance with a new set of objects. An example of this improvement can be shown with a custom model for electrical boxes. This dataset involved 6 training files and 2 validation files. As you can see from the table, with the old model, the training time required to achieve a validation accuracy of 85% was almost an hour. In comparison, the new model took just 12 minutes to achieve a validation accuracy 2.5% higher. That time saved can now be used to begin running your model on other data sets or trying different parameters to find the best possible combination for what you're extracting. Mustafa will now show what this looks like in TBC.
All right, thanks, Tavish. Let me go ahead and share my screen. All right, so I've got an outdoor scan project open here, and to get started, I've opened up the classified point cloud command right under the point cloud ribbon. And as we look at in the command pane, we have our classification type. So we have outdoor, both terrestrial and aerial. We have indoor, railways, and of course, your own custom models. Next, we'll go ahead and select our point cloud region. So I'll go ahead and select this region right here. And then you can also isolate specific classes that you want to classify. So you can go either ground, high vegetation, buildings. But for this example, I'll go ahead and select all the classes and I'll hit classify. This should only take a few seconds, but essentially what it does is it classifies the different ground regions, electrical boxes, and vegetation. And then also a really cool part of this is the refined classification. So with refined classification, if your region isn't absolutely perfect on the first pass, you don't have to start over. For instance, if the algorithm caught some messy pole bottom data, you can just check poles and signs and then hit refine, and it will automatically attempt to clean up those misclassifications for you. Now, what if you need to extract something specific that isn't in those default classes that you can extract? So this is where the speed improvements Tavish mentioned come into play. So right here in the training tab, we have where you could build your own custom models. So you simply load in the data sets that you want. You have your training data set and validation. And once you upload those, then you can analyze those files and you can define some classes. So for example, mapping a source LAS number to a custom class like electrical boxes. And you can also include another class if you need to, or as many as you want. Under the advanced settings, you could do a couple things here as well. So you can include properties like RGB color and intensity and tweak your training epochs. And the best part is when you do start training the model, as the model trains, TBC generates a live validation accuracy graph right at the bottom, and you can literally watch your model learn and improve over time. If you realize you need to make an adjustment, you can stop early without having to wait until the very end. And for those who really want to get under the hood, of course, we have the show tensor board, which is integration. So this gives you a much more detailed view, comparing all the different models that you've created and looking at the different MIUs, learning rates, all graphed out for your information. All right, so let's move on from classifying point clouds to extracting geometry. Tavish, back to you.
Thank you, Mustafa. Just want to point out, if you wish to learn more about custom classification, make sure to check out Trimble Learn or the Trimble Survey and Construction YouTube channel. There's a lot of good resources there. The next major enhancement introduced in TBC 25.20 are the changes to curb and gutter extraction, a feature contained within extract line features. These improvements include the new template-based extraction that uses patterns to save time when switching between extractable features. We've also simplified the QA review process by enabling editing of temporary nodes before creating line strings. And we've decreased the minimum interval for extraction, allowing extraction of sharp curves. The first change is the new template-based extraction. This now allows yourself, as the user, to switch between patterns that you define to extract features with different profiles, all in the same extraction process. You begin by defining your first pattern and clicking extract. Once a new profile is reached, you can select new pattern and define the new template to continue extraction. Once done with that pattern, you can either create more or return to an older one to continue. New in the February patch, returning to an old pattern is done automatically and does not require the reference node needed when switching back to an old pattern. As you can see in this video, the pattern is just quickly switched. The algorithm fits it to the curb, and extraction can just begin right away. This next improvement is the ability to do step-through QA/QC in the cutting plane view before finalizing any lines. With this new functionality, if users see a mistake in extraction, they can go and adjust it manually to ensure optimal accuracy without having to restart the extraction. This process lets you toggle through each extraction plane and select to move nodes via the cutting plane view. As you can see in this video, there's a cross-section that has a node out of place. Simply click on that node, move it to its new location, and continue on with your extraction or QA. We've also decreased the minimum extraction interval down to 10 centimeters for easier extraction of curbs. By decreasing your extraction interval around a curb, the fitting algorithm can more easily detect the curb and continue extraction without you as the user needing to point it to its next spot. As you can see in this video, that will hopefully load, there's a 180-degree turn in this median. By using the short extraction interval of 10 centimeters, it is able to extract it seamlessly all in one go. Mustafa will now demonstrate how these features look in TBC and how to run them with maximum efficiency.
I hope you can hear me. All right, so I've gone ahead and opened a second data set here. So what we have here is a mobile mapping data set that I've already classified. And to make our lives easier, I'll just use the View Filter Manager to isolate the ground region, just so we have a clean view to work with. With the extract line feature command open, which can be accessed again under the point clouds ribbon under extraction, we can select our curb and gutter extraction type. Next, we will define our template definition, specifically the cutting plane. So for the cutting plane, you'll define 2 nodes or 2 points. So one point can be on the road, for example, and one node will be on the sidewalk. Usually you want to make sure that those 2 lines are perpendicular to your curb, so this reduces the number of unnecessary scan points that need to be processed. But overall, it should speed everything up when the extraction happens. I guess we had a slight technical issue. Let me try to get this open again. But Tavish, just in case, I think we have a recording.
Yeah, one second. Mustafa, you may have to speak over top of it.
Or that works, no problem. All right, so yeah, so I'll be doing the exact same workflow here. So I'll change my filter to just ground only region, so this definitely simplifies the view. And what I'll do is I'll go next to hop over to the extract line command pane, and I'll select curb and gutter, and next I'll define my cutting plane. So I'll go to the plan view, zoom into the area where I want to start my extraction, and define those 2 points. So exactly the same thing. So I'll put 1 point on the road, 1 point up on the sidewalk, and this will generate my cutting plane cross section of the point cloud. So it will give me a nice view of what the curve profile looks like. Next, we'll go ahead and define our curve pattern. So you can define up to 10 nodes, but we'll go with the simple 4-node pattern here. Essentially, you just define different parts of your feature. For example, here, I'll define my back edge of the curb, top edge of the curb, my gutter flow line, and edge of pavement. Another tip is you can also click on the plan view or 3D view if it's easier as such. And then I'll go ahead and set my interval to 8 feet. This tells the software how far ahead to search for the next match. And then I'll leave my minimum confidence at 90%. So I'll hit extract and watch it work. So we'll go down this curb, down the road, and we'll see it extracting. And we can zoom in and interact with it in the 3D view. But as we approach the driveway opening, we'll notice that it does pause. So it is smart enough to detect that the curb profile is disappearing and the extraction automatically pauses. So sometimes it overshoots just a tiny bit to force a fit. So I'll hit undo once just to step back to my last clean profile. And this is where the new workflow shines. So what I'll do is I'll create a new pattern. So I'll hit new pattern, name it driveway, for example, and select OK. So when I do this, it automatically carries my current coordinates over. So since the concrete slopes down into the driveway, I'm going to use select next node point from the additional options. And I'll grab my flow line, which is node 3, as my reference node. I usually want to pick a line that's consistent across different patterns. I'll click down here where the pattern fully transitions into that full apron, and then I'll hit extract. Then I can quickly redefine the nodes in my cutting plane to match this flat profile. So by just clicking those node fields again, I can redefine that profile. And I could just say I want to up my interval to 16 feet instead. I can just go ahead and do that. We'll leave the minimum confidence the same. And then we can hit extract and let it extract across this driveway opening. As soon as we cross the driveway, the extraction stops automatically again because the vertical profile has returned. So instead of building a new pattern, I can just simply grab pattern 1 from my curve pattern dropdown. And then TBC looks back at those original forward coordinates that we've defined and reassigns the definitions to match our current location. So this saves a huge amount of time of manual clicking, and I can just continue ahead with my extraction by just clicking extract and proceeding from there. So I'll go ahead and just pause here and go over this other great feature. So while you're in the middle of extracting, you can step through your segments using the forward and backward arrows. And then I can move right back to my starting point, for example. So I'll click this arrow here, back to my original starting point, and I can make some edits here. So say I need to adjust a node, say tweaking the back of the curb, I can move it around, edit the line before it's ever finalized. So I'll zoom in here and show it in more detail. And then I'll click finish editing. So here, once I finish extraction, you can review your finalized lines. A common workflow here is when you're extracting a feature, you can define multiple nodes as helper lines to guide you, but just because you define them doesn't mean you might be interested in keeping them. So you can simply just select those unneeded lines and choose ignore. And of course, you can use those front and backwards arrows to scroll through those different extracted break lines. And depending on if you need them, of course, you have ignore, which will turn them into red, or mark, which will turn them into a white line, as shown here. So mark, you can flag it to review for later, but also if you're extracting, say, along straight segments, and say the line gets slightly jagged, you can use the line smoothing options like best fit line, which instantly cleans up those segments and keeps them perfectly in shape. Here's another example of where you can use it for jersey barriers. So it's not limited to just curbs. You can use it for retaining walls, guardrails, jersey barriers, and so on. And here we have it overlaid line work that we just generated on top of that original mobile mapping imagery. And that covers the feature extraction updates.
Thank you, Mustafa. This next edition is related to Agile assets. But before I jump into the integration with TBC, it's important to understand road networks. A road network is an inventory of all roadways that a transportation agency is responsible for managing, inspecting, and maintaining. Agencies managing large-scale road networks and pavement assets use a linear referencing system, or an LRS, which allows assets to be located along a linear road using a measure like mile point or kilometer marker instead of an XY coordinate. So then how does Agile Assets connect to that? Well, Agile Assets is an integrated transportation asset management solution. It allows you to make data-driven decisions about your infrastructure assets to deliver cost-effective, reliable transportation networks. And now it is integrated with TBC. Many DOTs inside the US, as well as some agencies outside, use Agile Assets to manage pavement data. The importance of this workflow stems from how transportation asset information is collected to enable planning, budgeting, and decision-making. This collection lands information in an asset lifecycle platform like Trimble Unity or Agile Assets. With collection possible through MX60 and MX90 systems, the question is then, how can we transform this data to information consumed by asset lifecycle management platforms? This integration with TBC enables creation of meaningful deliverables, transforming data to information. Furthermore, and you will see the application for this on the next slide, public agencies already have their segmentation. They wish to monitor the same segments over time to increase predictability, and that's the key value add with this integration, because now there are no data conflicts when pulling the DOT segments into TBC. The first application of Agile Assets is pulling road segments into TBC. Before this can happen, segmentation that I just touched on must be done in Agile Assets. Once this segmentation is complete, the road segments are pulled into TBC and used alongside road network analysis mode. For anyone already familiar with the pavement condition inspection command in TBC, this mode uses the predefined segmentation from Agile Assets instead of TBC creating segments based on a user set distance. From here, PCI would be run and conditions and scoring would be calculated in TBC. For those unfamiliar with the PCI command, there's a lot of information in the feature extraction updates in TBC 25.10 Power Hour that can be found on YouTube. And if you're interested in learning more about PCI, feel free to reach out to me via email. Once PCI has been run, the conditions can be uploaded back into Agile Assets, where each condition and its associated metadata is stored in the segment defined within Agile Assets. If only certain extracted aspects are wanted back, the user will have the option to only push certain segments or conditions. Jonas will now show what this looks like in TBC.
Good morning. So as mentioned, I'm going to demonstrate the road network workflow inside of TBC. So I'll share my screen here. All right, as you can see, I've got a mobile mapping data set that's already been processed and available inside of TBC. So the first thing I'll want to do here is navigate to the mobile mapping ribbon and launch the inspect pavement condition command. Here you will notice a couple new shortcuts that we've added. The first one being the download road network. If you have not previously authenticated before in Agile Assets, you'll be prompted to do so here. For right now, we'll go ahead and select the pull road segments. And TBC acknowledges how many segments have been pulled from the Agile Assets environment. Click OK. In the plan view, you can see here, this is one of the road segments that have been pulled in. It contains a couple of the feature attributes, one including the ID with 760 as the attribute value. Back inside of the inspect pavement condition command, we'll want to ensure that road network is selected under the analysis mode. From here, we can select the mobile mapping run where we want to run the inspection. we can select the road network segments, only after which you will see the unique segment identifier populate. And this allows for users to select different attributes that have been populated in AgileAssets to differentiate these segment names. Here we'll use the ID. Moving on to select lane lines, there's a couple options here. We can manually create these line strings that represent the lane lines. We have the ability to extract lane lines. This will launch the extract line feature command and provide two options to extract these lane lines, being semi-automatic and automatic mode. So moving on, we'll go ahead and select our previously established lane lines here. The lane line ID is an optional feature which allows an extension of the segment ID name that would pair with the ID. Moving down to the analysis parameters, we have a height and depth threshold, which essentially allows users to buffer out any scan points to be unincluded in the analysis. We want to enable detect cracks using ortholane. The reason we're using ortholane here is because there are additional features or additional attributes for these features that are detected. Users have the ability to analyze the road shoulder. In that situation, you would want to select the lane line closest to the road edge and provide a search distance. It's important to note that if your road segments are offset from your mobile mapping runs, you might need to increase the maximum distance from trajectory here under the PCI settings. We'll use 20 meters for our situation. Once that is complete, we'll hit confirm selection. You can see here that the selection that has been confirmed is now highlighted in the plan view, and we'll select the Analyze button. This should launch the analysis in the background. It's important to note here that several batches can be ran at the same time. Essentially, you would confirm the selection, navigate to the new area or mobile mapping run that you wish to run the report on, and then hit confirm selection for those items as well. And just a few moments here while the analysis finishes up in the background. Okay, so once this is complete, you have the ability to change the layer on which these attributes will be placed. You also have the ability to filter these attributes, or conditions rather, by low, medium, and high severity. And you can also filter out the classification type here. Once everything has been complete, we can hit confirm analysis. And you can see here that this the pavement condition inspection has named this segment 760, which correlates with the ID that has been pulled from AgileAssets. The final step in this process is to upload the pavement inspection conditions back to the AgileAssets framework. So we'll click on this shortcut button here. Now you can see that there are a couple different options to select these segments, or these segment conditions rather. You can select all, and TBC will note how many conditions have been selected. If you only want to include a certain segment into this AgileAssets framework, you could click the segment ID under the Project Explorer. From here, you'll want to select Push PCI Conditions, and TBC will acknowledge how many conditions have been pushed to the AgileAssets framework. That should be it for the AgileAssets portion.
Thank you, Jonas. Another option for connecting your mobile mapping data collected to a system of record is with the ArcGIS Feature Service. TBC has the ability to read and write features to ArcGIS using this connection. Writing features to GIS is used to push selected features through the connection, while reading can pull segments in. It can be used to upload mobile mapping, pavement condition inspection feature data to your feature service. Before we can jump in, though, we need to describe a schema. While a user can pull data without creating a schema, to push data back to ArcGIS requires it. Here's a simple workflow for creating the schema. First, you will take your pavement inspection project and export it to a geodatabase XML. From there, use the ESRI ArcGIS tooling to create feature classes in the geodatabase or in the feature service. If you use different feature class or attribute names in ArcGIS, make the corresponding changes to the alias property in the PCI feature aliases file that can be found in the location here. From here, the PCI schema is represented in your ESRI ArcGIS environment, and you're ready to write features to it. This is definitely a confusing step, so for a full breakdown of this workflow, check out the TBC tip of the week that will be posted to the community in the next 5 days or so, describing this process. Once you've established a connection to your feature service, you can read features from that feature service into TBC. This is specifically useful, as described before, if you have road segments in ArcGIS that you want to improve the reproducibility of analysis in TBC, similar to how AgileAssets work. On the other side of running PCI, you can transfer all conditions and sample unit information into your feature service in ESRI. As you can see in the image, the conditions overlay very accurately on satellite imagery and include PCI scores for each segment. This is in ArcGIS Online. Jonas will now show what this looks like in TBC.
All right, so I'll go over establishing an ESRI Feature Service Connection, reading features, and writing features. The first thing that's very important is the schema for the TBC project and ESRI Feature Service must match, otherwise you'll run into some pretty major issues. If you need to change the aliases to match those of the ESRI Feature Service, you can open up the PCI Features aliases JSON and then change these aliases as noted here. That will allow you to match the schema between the two. So from here, we'll navigate to the GIS ribbon. We'll launch the GIS Connection Manager. You can see here we have a previously established connection. In your case, you might want to select New. You'll then want to name the connection and select the data source type. There are several options here, but you would want to select the ESRI service. Once you hit connect, you'll be prompted for the feature service URL, which you can then paste inside of there. For now, we'll use the established connection that we have used already. So we'll then launch the read features from GIS command. If you were to have these road segments in your ESRI feature service, you would then be able to select them and import them or read them here. Since we have an existing road segment already in our TBC project, we'll focus on the writing portion. So from here, we'll navigate to the write features to GIS command. You can see that the previously established data connection has already been populated, along with the new and updated features. You can see here that the new features correlate with the new conditions that have been detected running the inspection itself. It would also show any updated or linked values here. In our case, we'll go ahead and select the OK button, and we'll write these features to the GIS. TBC acknowledges how many features were written to the ESRI feature service, and you have the ability to write and view a report. In this report, it essentially contains the number of features that have been written successfully, failed, or ignored. That should be it for GIS.
The final change included in TBC 2520 was the inclusion of multi-run processing for ortholane generation. Since a single data collection session usually consists of multiple runs, having the ability to select all runs at once and leave it to generate is crucial for efficiency. I'm sure anybody who has run this command is well aware. It is now as easy as selecting all the runs you wish to process, clicking generate, and coming back to a complete pavement mosaic. The UI changes to ortholane include the confirm batch button for each batch you wish to process and the option to discard the last batch. You will also see on your plan view that the run that was selected is highlighted. Precise selection is still possible, and you can select multiple batches that have been precisely selected. It is worth noting that even if you are processing ortholane for only one run, you must still click Confirm Batch after selection before running generation. Jonas will show this last enhancement.
Sure, let me share my screen here. Okay, back inside of TBC here, we will launch go to the mobile mapping ribbon and launch the ortholane command here. From there, we can select the mobile mapping run where we want to generate the ortholane imagery. We will enable the precise selection and provide a begin and end station for this area. We'll then hit Confirm Batch. As you can see here, the area of interest has been highlighted. We'll then navigate to an additional area of interest, select the mobile mapping run again, enable the precise selection, and provide begin and end stationing for this. We can then confirm the batch, ensure that our resolution is set for the optimal level, and click the Generate button. We can also do this with multiple runs, as Tavish has previously noted. Back to you, Tavish.
That concludes the reality capture data analysis enhancements in TBC 25.20, and we can start the Q&A portion of the webinar.
Thanks so much, David. Appreciate it. Guys, thank you so much. That was really great. Just one question that came up. Can we just talk a little bit about the data sets that we used, what we used to capture this and the density of it, and what is good density for these kind of workflows, and how does it work best, and what data sets to utilize for this?
Yeah, so these data sets are MX60 data sets, and which means the density is fairly good. If you have a coarser data set, the algorithms for curb and gutter may struggle to find the curb, but as long as the curb, the profile changes themselves are clearly defined, it should be able to still extract. You may have to do a bit more QA/QC or CAD editing on your own, but yeah, as long as the profile is still there, it should be possible to extract.
Okay. It seems like that was the only question we had. If there's any others, please add it to the Q&A section. If you have anything specific you want to find out or ask about any of the data sets, any of the hardware, any of the workflows, if you can go to the next, we're going to find the explanation of the pattern changes in curb and gutter. So if you want to find the explanation, it should be in the release notes, as well as in the help documentation. You will be able to find explanation of what the service can do now. Anywhere else where we can find anything like, I think it's just in release notes where will be the best part, and then in the explanation in the help will be the best part to go for what you can do there. Just go one back, Tavish, on the slide. Next one, will the recording of this presentation be made available? Yes, if you signed up for this, even if you haven't joined us today, you will get an email within the next 3 to 4 days to say that this was posted. All the webinars are being hosted in our YouTube channel at the moment. So if you go into the YouTube channel, which you can see on the ribbon in there, YouTube, you will find that. We will also update the link in the support tab here for Power Hour. That link will be updated, so it will take you directly to the YouTube channel where all the Power Hours are hosted now. We moved everything into there, so you can find all the videos we have in one spot. That one is done. That one is done. Next one, with the mobile extraction tool, can the workflow work with any mobile data, or is it Trimble system process within TBC? So for batch processing, that'll be MX Trimble data only. Am I correct, guys? If you want to do curb and gutter extraction, if you have a different data set from a different provider, yes, you'll be able to use that curb and gutter extraction, point cloud classification, all those tools will be possible to do. It's just when it comes to the actual processing of the data, we are focusing on the MX series from Trimble, and we don't support any others at the moment. So that's a quick one. Anything I forgot to mention, guys? I think the rest of the workflows, if you have a point cloud file, doesn't matter if you can import it into TBC. Most of the point cloud workflows you will be able to use in TBC.
Yeah, point cloud classification and the curb and gutter command can be used with any data source. Pavement condition inspection and ortholane processing do require an MX system to be used for data collection.
Okay, good. Yeah, so any of the extraction tools, even if you do lines, power lines, overhead lines, any of those things, line extraction, that can be done with normal data sets. It's not TBC, Trimble specific data sets when captured with MX for those ones. That one, thanks Garrett, thanks George. Besides the density for the point cloud, on the hardware side, what would you recommend to run this feature smoothly for curb and gutter extraction? So guys, any comments on what would be the best to make sure you have a smooth curb and gutter extraction when it comes to data sets, density of point clouds, and what they need to use to capture them?
I'm not the perfect guy to ask about MX systems, but that's the one I can answer somewhat for. It depends on the speed of collection. That's honestly the biggest setting. If you're going fast, you're going to want to use the highest speeding collection. And if you're driving slower, maybe in a more downtown area, a slower speed of collection would be fine. These use the point cloud, so any imagery settings don't really matter. All that matters is the speed of scanning.
Yeah, and just on that one as well, you can use terrestrial scanners as well. I mean, they will give you a dense enough point cloud to do curb and gutter extraction. It's obviously just going to take a lot longer. But if you have small little sections, let's say two intersections where it's not a big job and you want to use terrestrial scanning, as long as you capture the curb and gutter clearly with that terrestrial scanner, that point cloud will be more than good enough to do curb and gutter extraction. If you have a very good LiDAR system on UAV, you should be able to do it as well. It's just how good you can capture it and what the height is that you fly at. So again, density of point cloud and how clearly the curb and gutter is defined, any point cloud should be good enough. If you can see it clearly in the point cloud, curb and gutter extraction would be able to extract that for you. So don't think it's only going to have to be a mobile mapping system that you can use for this. Terrestrial scanners and LiDAR on UAVs, if you fly low enough and you get a clear definition of the curb and gutter in the point cloud, you will be able to use these tools to extract them. Let's quickly see, can I use paving inspection function instead of scan inspection function for the same result? No, scan inspection is a little bit different functionality. Paving inspection is specifically looking at rutting, cracks, alligator cracks, those kind of things. So the pavement inspection is specifically made for a specific set of data that we want to get out of it that is needed by guys to maintain the roads, to see where they need to fix it, where there is problems in the road specifically. Scan inspection is more to actually see floor flatness, see any deviation changes between, let's say, design and point cloud, or point cloud to point cloud if you want to compare that to each other. So those are two different workflows that have different end results that you would like to use for that. Did I miss anything in there? Did I, guys, jump in when you feel I'm going down the wrong path here? Thanks. Was more wondering about the inspection. Said good, Shane. Got you. What would you recommend for extraction of cables in open ground? Cables in open ground, when you do earthworks, that's a challenging one. I don't have a specific recommendation at the moment, George. As I said, if you can scan it and you can clearly define the cable, if it's completely exposed, if you only got half a cable, that'll be a little bit more different. Obviously, when you do extraction of those kind of things, the better defined the object is that you're trying to extract, the better your extraction result would be. So if you have the cables completely exposed and you can capture them, let's say at least 3/4 of the cable, chances are good that you will be able to extract it. If you only got like 1/4 of the cable captured, that'll be a little bit more complicated for the algorithm to try and extract it. So it very much depends on how good the data set is and how clearly defined the cables are, even if it's in open ground, what you can do with that. So that'll be on a case-by-case scenario, depending on the quality of the data set and how well defined the cables are in that specific data set. Also with curb and gutter function, yes, George, the same kind of thing relates there. The better the point cloud is and the better defined the curb and gutter is, the better result is you will get. When the algorithm needs to start guessing where it is, you'll see some funny results where it can jump in different directions. It's trying to make it the best fit. But if I'm correct, guys, if you set the accuracy of what you want to extract, the closer you set that to 100%, the more the point cloud will define if the curb and gutter can extract. So you can also play around with that setting to see how good the curb and gutter does. If you don't have great data set, you can maybe make that a little bit looser, maybe go down to 90% or go down to 80%. You might find a few false positives. You'll have to do a little bit more QA, but you will still be able to extract some of the data out of that. So depends on the quality of the data set, how well defined the curb and gutter, all the lines, all the power overhead lines are. That'll define how good the extraction is. And then obviously you can work with how accurate it needs to fit your template onto the point cloud. You can play around with that as well to see if you can get a little bit better extraction out of there. Yes, Mike, there is a problem at the moment on the support tab. You'll see there is a Power Hour icon under the learning side. That link is broken at the moment. If you want to find the webinars that we have, go to the YouTube one that you find under resources. We will update that link in the next patch we have out or in the next release to make sure that the Power Hours link into the correct YouTube link. But if you go directly into YouTube, there is a playlist for all the webinars, or you can just search them in that YouTube page that we have in there. That'll be the easiest way to find them. So thanks. We are aware of that link not being broken at the moment. When extracting curb and gutter for a curve in the sidewalk or median, it detects automatically is a curve by setting the interval to the minimum. So Mustafa, could you just explain a little bit again when you go around a curve? Obviously, the shorter distance will make it easier to go around the curve and how that works again. There's just a question about extracting the curve around the median, let's say, when it's a tight little curve. What's the best settings to extract that accurately?
Yeah, no, that's exactly right. So if you are dealing with a curved curb or any feature that does have very, I guess, smooth or sharp edges turning around, that's where you would use the smaller interval. It just makes it so you don't have any lines crossing over a bent shape. So when the smaller the interval, the better it will extract that entire curve. And of course, you also can do different smoothing operations for the QA/QC. So if you have line smoothing, you can do best line fit, or for curves, you also have another option for that, just to finally get that entire feature change. But yes, those are two options.
Okay, great. So yes, extracting a curb and gutter around this a sharp curve, or in the median where it turns quite sharply, smaller extraction settings will definitely help get around that curve much better. So yes, it would still do a good job at getting that for you when you set the interval to the minimum of, I think it is 10 centimeters, all correct? What's the minimum we can set that to?
That's exactly right. So it's 0.1 meters.
Okay, good. So that is the minimum. That will definitely help when you go around sharp curves to extract that better. Good. I think we got through all the questions. I don't see anything else popping up at the moment. Thank you so much, everyone. Just quickly on the resources, people asking, where can I learn more? Where can I find more information? In the support tab in TBC, that is where you will find all the needed information. Tutorials is a great way to start off with if you want to see a specific workflow and get a small little sample data set, get a step-by-step guide to work through that. Tutorials is a great way to do that. On the e-learning side, that's where we have the virtual machine environment. So if you don't have a mobile mapping license, which we know not a lot of people do have, and you want to go test it out, you can go into the e-learning environment. There is specific courses on how to use mobile mapping data, how to process it. In those learning courses, we'll give you a license of TBC in that virtual machine, so you can actually run through those workflows with a sample data set and the step-by-step guide. So great way to test out, even if you don't have the point cloud functionality in TBC and you want to see what it's like to extract open gutters or to do overhead power lines, again, that e-learning environment gives you a full license and you can go test all of that out in that environment to see what it's like before you decide to dive a little bit deeper into TBC. As I said, the Power Hour link, we are aware that is broken at the moment because we shifted all the recordings over to YouTube. We'll fix that. Then the next one is the YouTube channel there that you can see. That's where we do the smaller 5 to 10 minute videos on a specific workflow. We deep dive a little bit more, and then all the Power Hours will be in there. Geospatial and construction websites if you need any more information. Then we do still have the promotion running for the subscription trial licenses where you can actually get a license to test out if you want to install TBC on your PC and test it out for yourself. That license gives you a 30-day demo license for subscription, and you can then go and use it for that amount of time to test out TBC in your own environment with your own data sets if you want to do that. Anything I missed, guys? I think I covered everything that we needed to. Oh, the one thing I just wanted to mention, I did forget to add that slide, is the Field Systems Help Portal. It's a long name, but if you want any information on any of the hardware or software products in the Field Systems business area, so that'll be all the GNSS, all the total stations, mobile mappings, laser scanners, software, TBC RuleWorks, Access, SiteWorks, all that. Go and look for the fieldSystemsHelpPortal.com. That will get you into that environment. TBC has a full page there where all the information is, all the resources are linked in there. The help has been uploaded there, so you don't have to install TBC to use the help. The help is in that web interface as well, so it's a great resource to try and search for what's going on. And you'll get all the information, all the software matrices is there. So if you want to see what software license you need to get a specific functionality, that is all linked into that Field Systems Help Portal for you to look at. Good, and that I think I have covered everything I needed to. All the questions are done. Nothing has popped up again. So guys, thank you so much, Davies, Jonas, and Mustafa for your time. Appreciate the demos you did. Looks like it was really well received. We had a good few questions come through. So thanks everyone for your time as well that you spent with us today. Thank you so much. Hope you have a good rest of your morning, afternoon, or evening, wherever you might be. And hopefully we'll see you for the April Power Hour again. And with that, I'll give you an extra 7 minutes of your time back early, up a little bit earlier. So thank you so much, guys. Appreciate it, and catch you for the next one.